Numerical analysis is mainly going to deal with the approximate solution. Whatever the number I'm going to get before the dot, it is in the form of integer. 3-digit towards right. Towards right in the sense what? It is always positive power. Hello to all, a warm welcome to my new subject, that is numerical and statistical analysis. Under this subject, I am going to deal with the topic that is computer arithmetic. I am Revati, faculty from the Department of Computer Science, Vidhyaashram, first grade college, the Temple of Excellence, MYSURU. So dear student, in my today's session, at the beginning, I am going to deal with definition of numerical analysis. Along with that, I am going to deal with approaches to store real numbers. Along with that, I am going to discuss use of numerical analysis. Before that, tell me why B.C.A student want to study this subject. So dear student, if I consider computer system, computers are able to understand only instruction, and whatever the instruction I'm going to provide, that is in the form of zeros and ones. There is nothing but computers are able to understand only machine instruction. If it is machine instruction, then it is nothing but the binary digits, that is zeros and ones. Now, if I consider some of the fields like artificial intelligence, machine learning or deep learning or neural network, even I can able to consider digital image processing. So these are the certain field we are going to play with the numbers. So to play with the numbers, we have to study this subject. So that is the usage here. That means we are the computer science student, but still why? We have to study this subject because these are the certain field we are going to use number system. And if I consider computer number system, we already know that there are 4 types of number system. One is binary, then octal, decimal, hexadecimal. So these are the number system we are going to use. Along with that, in our subject, we are going to study why we have to study floating point numbers, how to represent floating point numbers, all those things we are going to study in my today's session. So dear student, at the beginning, I am going to have the topic called definition of numerical analysis. So what is the topic of the day here? That is definition of numerical analysis. So what is numerical analysis? Numerical in the sense what? It's nothing but the numbers, and I'm going to analyze the number. So it is a branch of mathematics. That means numerical numbers are always comes under mathematics, which deals with the approximate solution of mathematical problems. That means here numerical analysis is mainly going to deal with the approximate solution, not exact. It's around approximate solution of mathematical problems. Now, then what is the advantage here? That is, it is very easy to use. Because if I consider numerical analysis, we are going to have different methods and different iteration. By using all the existing technique as well as technology, we can able to find the approximate solution. So it is very easy to use, and it can produce result quickly. That means if I use numerical analysis, then it's very easy to produce the output and within fraction of second we can able to generate the result. Then what is the disadvantage? If I go with numerical analysis, then I won't get exact result. So what's the disadvantage? If I go with numerical analysis, then I'm not going to get exact result. That means whatever the result I'm going to get, that is approximate result. Now, what is the use of numerical analysis? That means why I have to study the subject, what is the need and which are the area we can able to use numerical analysis. So dear student, if I consider engineering science, if I consider engineering field as well as scientific field, we are going to play with the numbers. So if I consider engineering science like machine learning, deep learning, machine learning, then neural network, along with that digital image processing. These are the certain area we can able to come across numerical methods or numerical analysis. Then if I consider social science, in the field of social science, once again we are going to play with the numbers, as well as if I consider business sectors or business field, once again we are going to play with the numbers. So these are the certain field we are going to come across numerical analysis. Now I'm going to have the topic that is approaches to store real number. Now the question arises, what is real number? So dear student, if I consider number system, I have two kind of number system. One is whole number, and another one is fractional number. So one is whole number, then another one is fractional. So what is whole number? For example, if I have integer, so this integer always represents whole number. Example, 10, 20, 100 and 1000 and so on. If I consider fractional numbers, so dear student, if I consider fractional number or real number, I have two parts. One is integral part, and I'm going to have the decimal point, that is dot, then I'm going to have fractional part. So these real numbers are represented in the form of integer, dot, fractional. For example, if I have 3.1412, this is the example for real number. This is nothing but the floating point number, or it's nothing but the fractional value. So whatever the number I'm going to get before the dot, it is in the form of integer. And whatever the number I'm going to get after the dot, while reading, I'm going to consider one digit at a time. That means I cannot read 1412. It is wrong. How I want to read? That is 1412. That means I'm going to read, or I'm going to consider one digit at a time. Now, what are the approach? We have to store real numbers. That is two kinds or two types. One is fixed point notation. So one is what? It is fixed point notation. And another one is floating point representation. So dear student, to represent real numbers, I have two types. One is fixed point notation, and another one is floating point representation. Now, to explain fixed point notation, let me to write the example. For example, say I have 3.1412. So what is this fixed point notation? That means after the dot, whatever the digit I'm going to get, I'm going to fix the length of the digit. For example, here it is 4. That means I'm going to fix the digit in the sense after dot I can able to use 4 digit. So in this there are a fixed number of digits after the decimal point. That means I'm going to fix how many digits I want to use after the decimal point. Now, the another method here is floating point representation. Now, dear student, let me to consider the example here. I have 100.12345 So, here after decimal point, I'm going to have variable length of digit. I repeat, after this decimal point, I'm going to have variable length of digit, and that is known as floating point representation. So, it allows for a varying number. So, the floating point number can be varied according to the user need. So, here follows for varying number of digits after the decimal point. That means after my decimal point, I can able to have variable length of digit. Let me to write the example here. Think that I have 3.1412. So this is my floating point number. Now, this 3 is nothing but my integer or integral part, and this is itself known as mantissa. Okay, then I'm going to have dot. This is decimal dot. After that, I'm going to have the base. Then I'm going to have exponent. So after that, I'm going to have the base. Then I'm going to have the exponent. So what is base? Here base is used to represent what kind of number system. For example, if it is binary number system, then what is the base? It is 2. If it is octal number system, then what is the base? It is 8. If it is decimal number system, then what is the base? It is 10. If it is hexadecimal number system, then what is the base? It is 16. Then what about exponent? That's nothing but the power. Suppose if I write 10 to the power 2. So 10 to the power 2 in the sense what? This 10 is nothing but the base. And this 2 is nothing but the exponent or e. Now, dear student, if I consider fixed floating point number, it has 2 parts. One is signed fixed point number. So, if I have plus or minus, that means I can able to have positive number even though I can able to have negative number. So this plus and minus is nothing but the sign. Okay, so it is signed fixed point number is called mantissa. That means this part is called mantissa. Part of a number located after the decimal point. Okay, now position of the decimal point is called exponent. So e to the power e. So what is mantissa? It's nothing but the fixed point number is called, that is signed fixed point number is called mantissa and whatever the number, that is whatever the digit I'm going to get after my decimal point, that is nothing but the exponent. Now, use of numerical analysis. That means how I can able to use numerical analysis. So, a floating point number can be represent a very large or very small value. That means by using floating point numbers, I can able to represent large value, even I can able to represent small value. A floating point number is typically expressed in the scientific notation with a fraction f. So, if I have fraction, then it is represented as f. As all exponent, that means to represent exponent, I am going to use the letter E, and to represent radix. So here radix is nothing but the base. So here radix is nothing but the base. So this is the decimal number. And this is nothing but the binary. So here base is 2. Here decimal is nothing but 10. So base is 10. So a number in scientific notation with no leading zero. That means whatever the floating point number I have, and if that number does not start with the value 0, then it is termed as normalized number. Now, dear student, let me to consider the example here. Think that I have a number 0.001, 0.0000. Think that I have around 10 0 after that 5. Now, if I store this number in computer memory, what's going to happen? Each digit is going to occupy certain memory block. Now, to represent this small number, I want to waste the memory. Instead of that, what can I'm able to do? That is 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Okay, that is I can able to write 10 to the power 11. So, how many memory location I required? I required one memory location to store 0 and to store base and to store exponent. That means by using floating point representation, I can able to save the memory. That means instead of wasting memory, I can able to save the memory. Now, see, I have the next topic, that is normalized number. So, dear student, as we know that the number which is going to start from 0, then it is not normalized number. Then, if I want to normalize the number, then the number must start from the 0. See here, if I consider this example, the decimal point here is 1.23 into 10 to the power 2. Okay, that means this one indicates that it is normalized number. That means it is going to satisfy the condition. So then what is the condition? That is a number is scientific notation. That means a number in scientific notation with no leading zero. With no leading zero is called a normalized number. Now, if I consider this one, I have 1. That means there is no leading zero. Obviously, it is normalized number. And if I consider this one, this is also normalized number. Now, if I consider third example, see, I'm having leading 0. so it is not normalized number. And if I consider this one, it is also 0. That means it's going to start from the 0, so it is not normalized number. Now, computer arithmetic that supports such number is called floating point. That means a number which supports normalization, then it is called floating point number. Now, this is the normal number. Think that I have some normal number, say 55.66. Now, I want to convert that into floating point representation. So, what I'm going to do? I'm going to shift this 5 towards right. How many bit I'm going to shift? 1 bit. See here, I'm going to shift 1 bit and it is decimal number. For that reason, 10 to the power 1. Now, in the next time, I'm going to shift 1 bit towards right. So, it is 2 bit, 0.5566. So, how to read? It is 0.5566. That means whatever the digit I'm going to get after decimal point, I want to consider. That means I want to read 1 bit at a time. I cannot consider whole bit. I want to consider one bit or one digit at a time. Now, the fractional part can be normalized. In the normalized form, there is only a non-zero digit before that radix. Okay, see here, I have the example that is 123.4567. That means if I want to normalize this number, then what is the rule here? The fractional part can be normalized. So what is the fractional part? This one can be normalized if there is only one non-zero digit before the radix. So this is the answer. That means I'm going to shift 2, 3 towards right. That means to normalize the given floating point, I'm going to shift the number towards right. When I shift towards right, my power is always going to increment. And another situation, if I shift my fractions towards left, then the power is always going to decrease. For example, think that I have 0, 0, 1, 2, 3. Now, I want to normalize this one. So, what I will do, I'm going to shift these 2, 0 towards left. Then, now tell me, is it normalized number? No. Because my normalized number always starts from 1. That is non-zero number. Now, once again, I'll shift towards left. Then 1.23 into 10 to the power minus 3. See here, when I shift towards right, I want to increment the power. When I shift towards left, then I want to decrement the power. So, what are the rules I want to consider while normalizing? Rules for changing floating point to normalized mantissa made less than 1 and greater than or equal to 1. That means while changing mantissa, okay, while changing the floating point to normalized mantissa, then the mantissa must be less than 1 and greater than or equal to 1. So, the mantissa may lies between 0 to 1. That means in between 0 to 1. Exponent is the power of 10. So always exponent is the power of 10, which implies the mantissa. So I'm going to write 10 to the power 2, 10 to the power 3, 10 to the power 5. Okay, these are the two rules we have to consider while normalizing the number. So here I have certain problems. Here I have 443.763. Now represent the following real number in normalized floating point form. So what I want to do? I want to represent the following real number in the form of normalized floating point number. So if I consider this example, it is not the normalized floating point. So what I want to do? I want to normalize it. What I'm going to do? I'm going to shift 3 digit towards right. Towards right in the sense what? It is always positive power. So 10 to the power 3. Now if I consider this one, I have 25376.73. That means I want to shift 5 digit towards right to make it normalized number. So it is 10 to the power 5. Now I have 1.73457. To make it normalized number, what I'm going to do? I'm going to shift this number towards right. When I shift, it is 0.173457 into 10 to the power 1. Why it is 10 to the power 1? Because I'm going to shift only one bit. Now, here I have 2.35679. Now, what I want to do? I want to shift this bit towards right. So, how many bit? I'm going to shift one bit. Now, it is 0.235679 and it is power to the 1. Now see here, to make it normalized number, what I want to do? I want to shift first 3 zeros towards left. When I shift towards left, what is my power? It is minus. So minus 3. That is nothing but I'm going to shift towards left. So remember, when I shift the digit towards right, then power is going to increment. When I shift towards left, then power is going to decrement. See here, I have 5 zeros. Along with that, 73457. To make it normalized number, what I want to do? I want to shift 5 digit towards left. So, when I shift, it is 10 to the power minus 5. So, dear student, this is the way I can able to normalize the given floating point number. Anyway, dear student, in my today's session, I started with what is floating point number and what are the different kinds of floating point number. Along with that, how to convert floating point number to normalized floating point number. And in my next session, I'm going to deal with add, that is addition and subtraction to floating point numbers. Along with that, I'm going to deal with errors in numbers as well as problems. Anyway, dear student, let's meet in the next session with more information about computer arithmetic. Until that, keep watching and keep learning. Thank you.